guys, welcome back to my channel. So in my previous video, I've just begun with the chemical bonding chapter where I have discussed about the concept of chemical bonding, the types of chemical bonding compounds, whether they are electrovalent compounds and covalent compounds, what are the conditions required to form electrovalent compounds and covalent compounds. So today I will be doing with you certain examples of electrovalent compounds. So before beginning with the examples, you need to know what is a electrovalent compound. Electrovalent compounds are those compounds which involves a transfer of valence electrons from one atom to another atom. Okay. Now in your syllabus there are three main examples of electrovalent compounds. Number one is the formation of sodium chloride. Number two is the formation of magnesium chloride. And number three is the formation of calcium chloride. I will be teaching and elaborating each of the examples in details. So let's begin. Now, the first one is the formation of NaCl. NaCl, that is sodium chloride, is formed as a result of transfer of one valence electron from a metallic sodium atom whose electronic configuration is 281 to a non-metal chlorine atom whose electronic configuration 287. So now the question arises, how do this compound attain stable electronic configuration? So individual atoms attain electronic stable configuration. Sodium atom attains electronic configuration stable of the nearest noble gas neon just by losing one's electron present in its valence shell and become positively charged to form sodium plus. What I said was Na has electronic configuration 281. If it loses one electron, minus electron, it will form Na plus, and this Na plus is formed after loss of one electron whose electronic configuration will be 28. This is the electronic configuration of neon. Similarly, chlorine, which has 2, 8, 7 as electronic configuration, if it gains electron, it will form Cl minus, and it will have an electronic configuration of 288, which is of a argon. Okay. Now, as two oppositely charged ions are formed, they will attract each other, resulting in the formation of electrovalent compound, that is sodium chloride. Okay. There are three ways by which the formation of NaCl can be represented. The first one is the ionic equation method. The second one is the electron dot diagram, and third one is the atomic structure diagram. Okay, so let us deal with each of the ways of representation in details. Now in ionic equation, the first step is the oxidation. What is oxidation? Loss of electron. Who will lose electron? The metals. Here the metal is sodium. Sodium loses an electron and will form Na plus. See, second will be the reduction, which will Cl will gain one electron to form Cl minus. Okay. Now as they are opposite charge, if you add these two equations, they will you will get Na plus Cl give Na plus Cl minus, there is an attraction between them and it will form NaCl. This is the electrolytic compound. But in your exam, you do not get question based on ionic equation. You get question based on the second method of representation, that is electron dot diagram. Now, you know sodium has 1 electron in its valence electron. Okay, and chlorine has 7. 1, 2, 3, 4, 5, 6, 7. Okay, I have represented the electrons in 2 different ways. You will also do the same in your exam. Now you see this electron will be transferred to chlorine. So after electron is transferred, sodium will become sodium plus and chlorine will gain that electron to form octet. Okay, and they will combine to form NaCl. Okay, in exam you need to mention here transfer of electron. In exam you will be asked draw an electron dot diagram to show the formation of NaCl and state the kind of bond present in it. So you will just draw the diagram with pen and pencil and mention the type of bond present. The third method of representation is atomic structural diagram. This is the orbital diagram one. Okay, has 3 shells because present in period 3. So the first one, the second one, and the third one. So here 2, 2, 3, 8, and 1. Plus chlorine will have 7 repellence electron. 3, 4, 5, 6, 7. 1 electron will be transformed from here. You will form sodium with 2 shells. Okay, here 2 electrons and here 8. Chlorine will also have the same thing. 1, 2, 3, 4, 5, 6, 7, 8, and it will form NaCl. Okay, in exam, this is the most important one. Now the next example that is there in a syllabus is magnesium chloride. Here also we'll see that magnesium chloride is formed due to the transfer of 2 valence electron, because the electronic configuration of magnesium is 282. Therefore it has the ability to lose 2 electrons. So when it will lose 2 electrons, it will have an electronic configuration of 2,8 as shown here. Okay, see, magnesium is losing 2 electrons. Now when you are forming a magnesium chloride, MgCl, we need to form this. You have seen in the previous slide itself that chloride has an electronic configuration of 287. So it has a capacity to accept only one electron. But magnesium is donating 2 electrons. So where will the other electron go? So in order to maintain the electrical neutrality, that 2 electrons are donated and 2 electrons needs to be accepted, 2 chlorine will accept each 1 electrons. Okay. Therefore, we write as 2Cl plus 2 electron will give 2Cl minus. This is the ionic representation, and on combination, when they combine after the transfer of electron, they will form MgCl2. Okay, now this is the electron dot diagram. I will show in the next slide, and this is the orbital diagram. You just need to visualize the diagram because question do not come from this orbital diagram and your ionic equation. Question only comes from your electron dot diagram. So the electron dot diagram for MgCl2. Okay, now we see magnesium in its valence electron will have 2 electron, and chlorine has 7. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. So magnesium will donate 1 electron each to the chloride atoms. Okay, and after it has donated 2 electrons, it will have a doubly charged positive over it, and chlorine will have this 8 electrons outermost shell and will form MgCl2. Okay, the third example which is there in your syllabus is the calcium oxide. Here also we will be seeing 3 ways to represent calcium oxide, and calcium oxide is formed when calcium transfers 2 of its valence electron to the oxide ion. You all know that calcium has the electronic configuration of 2882 as seen from the ionic equation. So it has 2 valence electrons, it will donate 2 electrons and it will form calcium 2 plus. It will have electronic configuration of 288 which is of argon, the noble gas. Similarly, oxygen has an electronic configuration of 2,6. So it will have a tendency to gain 2 electrons to form 2,8 in order to attain the inner gas electronic configuration of neon. Okay, so when these two oppositely charged ions come close to each other, they will form calcium oxide. Okay, similarly, you can see the electron dot diagram where 2 electrons are being transferred from calcium to oxygen, and calcium will bear a 2 plus charge and oxygen will have a 2 minus charge, will form calcium oxide. Orbital dot diagram is also shown here, which you just need to see for your visualization. Okay, so I'm stopping here today. Please do like my video, share it with your friends, and hit the like button and subscribe my channel. In the next video, I will be dealing with the covalent compounds. Thank you.